Okay, I'm going to run through the three problems that are here on the back side. Starting with the top one, you are given 0.00356 liters. Now, it doesn't really matter which direction you head. I'm going to go ahead and head to the top here. In proper scientific notation, I know that that's going to be 3.56. And the way that we're going to have to do that is we're factoring out 1/10 three times. So dividing it by 10 would get it to there. Dividing it by 10 again would get it to there. And dividing it by 10 would get it to there, which is where we want it. Okay, and so I end up with 3.56 times 10 times 10 times 10, which is the same thing as 3.56 over 10 times 10 is 100, times 10 is 1,000, or 3.56 times 10 to the negative third. Again, those are all liters, liters, liters. Now on this one, we said that the bottom row is in chunks of 3. We already moved it a chunk of 3. This is already a power of 3/10. So this bottom one is going to be the same as the top here. So I'm going to go straight to this step here, which is getting it into the proper unit. 10 to the negative third, if I look on the chart on the other side, 10 to the negative third is milli. So 3.56 milliliters is a better unit and gets rid of my scientific notation completely. And then I could write 3.56 ml. For the next one, this one's got a lot of zeros because I'm given 89 gigabytes. I'm going to start this one actually going down first. It doesn't really matter, but I think it makes more sense to me to write 89 and then look up to see what giga means on the chart, and giga means 10 to the ninth. Okay, and now the giga is gone, so this is just 10 to the ninth bytes. And that's the same thing as saying 89 times 1,000, a million, a billion. Sorry, ran out of space there. 9 zeros is a billion, which is the same thing as saying, oh man, this one's hard, times 10, times 10, times 10, times 10, that's 4, 5, 6, 7, 8, 9. Right? Okay, now that bottom row is done. To get us up here in the top spot, we would really want to factor out, well, I guess let's go to the middle box first here. If I multiplied all this out, 89 times 10 is 890, times 10, 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 which gives us 9 zeros, or 89 billion bytes. Now, up at the top, we know that this would be 8.9 times 10 to the something. To get this, we know that you could think about it this way. We could factor out that 89 and take a factor of 10 out and make it 89 times 10. That gives us one more 10. So, I need 10 tens now. 3, 4, 5, 6, 7, 8, 9, 10, which is the same thing as saying 8.9 times, this one's not going to be 1 billion, it's going to be 10 billion. So that's, or 8.9 times 10 to the 10th bytes. And then we could abbreviate here in the middle and just say 8.9 GB. Oops. Okay, third one. We're given 754 nm, which is the same thing as saying 754 nanometers. Again, I think it's easier probably to go down here on the bottom and say 754 nanometers times 10 to the negative ninth, and now that's just meters, which is the same thing as saying 754 over, because negative exponent, 3, 6, 9 zeros for 1 billion. And then this one's got a lot of tens. 10 times 10 times 10, 3, 4, 5, 6, 7, 8, 9. Okay, now we know that if we wanted to get this to be 7.54, we would be dividing it by 10 two more times. And this is where I really see a lot of mistakes in scientific notation, as you know, that you've got to swoop two more spots. But is it going to be 10 to the negative 7th, or is it going to be 10 to the negative 11th? And if you think about that, you're going to need to divide it by 10 two more times. So this one, to get 7.54, 10 times 10 times 10, 3, 4, 5, 6, 7, 8, 9. We got to do two more to get 10 to the 11th. I'll come back and get that last box here in a second. 7.54 now. We can put a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros by it, which is 100 billion. And this one, we could say 7.54 times 10 to the negative 11th meters. Okay. So finally, thinking about what that number actually is. Again, every time you divided this by 10, it would get smaller and move one spot to the left. So we can go, I'm going to write over here, 754. One spot to the left would get our decimal here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's double check my zeros there. I should have 1, 2, 3, 4, 5, 6 zeros. Pause for a second here while I count. So yep, that should be good. So altogether, that's 3, 6, 9, 10 zeros, and then there, and then this little dot that I drew there as my starter would go away. Sorry, oh, I messed that all up. Okay, that was the third one. Finally, the fourth one. Let's take a look at that. This one you were given 1 times 10 to the 5th acres. Okay, I'm going to work backwards from here. That's 100,000 if I multiply all that out. Now this one, since the number was 1, it actually works out kind of easy. But we could say 1 times 10 times 10 times 10 times 10 times 10. And so this box and this box actually end up being the same. Now this one, if we're moving in chunks of 3, we could say that this is 100 times 10 times 10 times 10, which is a little bit different. And that's, again, our acres. So now we could say this is really the same thing as 100 times 1,000 acres, which is the same thing as saying 100 times 10 to the 3rd acres. So now I can say that this is 100. 10 to the 3rd means kilo acres, or 100, I'm going to guess KA is going to be my abbreviation. Okay, hope that helped a little bit. We'll practice more on scientific notation tomorrow.